Welcome to the numerous WebKit SIRS Epidemic Modeling web app. This is instructional video 4. In this video we will present the compartmental flows for the SIRS+DTV model. We'll discuss the treatment function options, constant and adaptive, the vaccination function options, constant and adaptive, and demonstrate the sensitivity intervention mode of the app. Before proceeding, the user should be familiar with the run mode implementation, which they can study using instructional video 1. The SIRS+DTV model is an extension of the regular susceptible, infectious, recovered model with treated, vaccinated, and dead classes added to it. The mathematical notation we use in our technical document to denote the flows is the symbol rho subscript xy, where x and y can take on the letters S, I, R, V, T, or D. So, for example, rho SI will be this flow, while rho RS will be this green flow. Bring up the app and select the intervention mode. Before proceeding, we'll talk about the 3 intervention RAMs that can be selected over here. First, we will consider the infectious to treated RAM, where RAM stands for Runtime Alterable Module. Click over here to select the infected to treated RAM. Once you've selected it, you have the selection of the constant or adaptive options. The constant option is just rho IT is equal to the treat rate, which is a constant. So select the RAM, select the constant option, that's the math expression, and that is the RAM code. If you select the adaptive option, then you'll get an exposition of the math expression over here, and in the instructional manual the equation for this option is the actual treatment rate is the treatment rate as long as this rate is less than treat capacity. If it's greater than treat capacity, then this rate will be 0, which means there's an upper limit to the number of individuals that can be treated. And then, of course, here's the code that expresses this in the RAM. Let us now consider the susceptible to vaccination or vaccinated RAM. Click here to select the susceptible to vaccinated option. Select the RAM. Here is the constant option. The constant option is just the flow rate is equal to the parameter that we've set called vac rate, and the RAM code is V subscript rate. Select the adaptive option, and up will come a version that has this expression. This is the RAM code, and in the instructional manual, the actual vac rate is going to be the vac rate provided T is greater than the vac onset time, and the number vaccinated is less than equal to vac max. Otherwise, the actual vac rate will be 0. The immune to vaccinated RAM, we can select that, The constant and adaptive versions of this RAM are the same as the SIRS+DTV expressions. However, this immune to vaccinated RAM has an additional user option, and there's going to be an additional slider associated with this option in case the user wants to have an expression for the immune to vaccinated rate that's different from the susceptible to vaccinated rate. That is, individuals known to be immune will not be vaccinated, and this can be put into an additional expression over here. Now let's go to the sensitivity mode of the interventions. Now we select the intervention sensitivity mode, and we'll start with the default presets that come up, which is sensitivity on the baseline contact rate, 10 runs going, or 11 runs going from 0.5 to 1.5 in increments of 0.1. Okay, now that we've done this, let us choose some presets that we've put in that has the susceptible to vaccination and immune to vaccination, the adaptive selection. We've set the different disease, vaccination, and treatment rate parameters to various values as seen. Now let's start this run. And in this case, the sensitivity is on the vaccination rate parameter. We have 11 runs going from 0 to 0.02 in increments of 0.002. Now that this run is complete, we can choose to plot different variables as you see. For example, these are the deaths, the vaccinations, and the treatment numbers under these set of parameters. Okay, now that we've made this run, we can download the CSV file if we'd like to analyze it further. This is the end of video 4. Thank you for your attention.